tech behind Artifacts, and I want to thank B-Day for hosting me and for organizing Sasha and Paco couldn't be here today. He's dying, so. Yeah. So okay, let's get started. So hi, my name is Eddie Lee, and I work at a company called QGames. We make video games for PlayStation 3, Nintendo 3DS, Nintendo DS, PlayStation Vita, PSP, Facebook, PC, and at QGames, I am a graphics designer. And just personally, I love everything about graphics. You know, like Perlin noise, subsurface scattering, global illumination, just anything that has real-time procedural graphics. I'm all on its nuts. And it's personally the reason why I like graphics programming is sort of the intersection of three of the passions of my life, which is mathematics, programming, and art. And I really cannot see myself doing anything else. So what is this talk about? So, as I said earlier, this talk is about this project, or this side project I'm working on called Artifacts. And Artifacts is a real-time demo. So real-time as in it's rendered in real-time, like a video game or music visualizer. And it's my submission for the Tokyo Demo Scene 2013. Does anyone know what Demo Scene?
Yeah, we had a presentation last time on this.
Oh, really?
Yeah.
It's basically like a group of nerds like myself get together and try to compete. And yeah, it's actually in 2 weeks, so if anyone wants to go to Tokyo, you put this up, hit me up. And the specs for this is 720p, it's 1280 by 720 at 60 frames a second. And so far, I've been developing this on and off for about a month now, and well, because like winter break and New Year's and stuff, I was able to commit as much time to it as I wanted to, but still I think it's not a total embarrassment, so I decided to talk about it. And it's a music collaboration, or it's a collaboration to me and someone else. I'm doing the graphics and the programming, and then this guy called Kazao is doing the music and the sound design. And Kazao is a Tokyo-based electronic artist. He does down-tempo, a lot of ambient stuff, and actually he did the music for the Tokyo fashion show runway theme or whatever. So he's pretty legit. I'm pretty happy with what he's giving me. And it's really quickly about the graphical style. I was sort of going for alien artifacts in space. You know, like 2001: Space Odyssey. That feeling of like wonder and mystery you get when like a human race encounters an extraterrestrial thing. I think it's very powerful, and I try to capture that, or give, And then the color scheme is pretty simple. The CMYK, try to just retro, kind of non-pretentious color scheme. And the tech behind this demo is I coded mostly in C++. I coded in my own little personal engine called the Funk Engine. And it's a little game engine that I've been developing on my free time at home and during lunch and stuff. And yeah, it's definitely it's usable. It's definitely not as powerful as like Unity or Unreal, but it allows me to just get prototyping and just get stuff on screen really fast. So for graphics, I use OpenGL. It's kind of a no-brainer. It's a cross-platform. It works on Windows, Mac, Linux, Android, iPhone. PlayStation 3 has a variant of OpenGL. PlayStation Vita, anything with the PowerVR graphics card, I think has a variant of OpenGL, right?
So sorry, when you say OpenGL, does it mean also OpenGL ES?
No, it's not using the OpenGL
okay.
ES subset, but yeah. And for compute, or just harnessing the power of the GPU, doing GPU stuff like fluid dynamics or whatever, I use OpenCL. And then I use GameMonkey, which is a scripting language. It's the same scripting language that we use on our PixelJunk, the PlayStation 3 PixelJunk titles. And I embedded this scripting language into my C++ game engine, and it allows me to quickly iterate and quickly converge into the idea or whatever I want to quickly refine. And yeah, so that's just a little brief overview. And so in my demo, there are 3 scenes. The first scene is called Obelisk. And basically I'm trying to go for a metaphor of butterfly in a cocoon, coming out of the cocoon and spinning and swinging, flying away, and kind of artsy shit like that. And anyways, so it starts off with like this core thing encaps in the glowing white shell. The shell breaks open, disintegrates, and then these wings starts to spread out. And actually these wings, if you're curious, they are 3D splines, and I affected vertices in the vertex shader, and I did some benchmarks. I was able to get about 1 million of these splines, and seems to be like on the GPU vertex bound. Usually when you do graphics, it's field rate bound because there's more pixels generally than vertices. So, yeah. And for the second scene, it's a scene I call Glitter. And then for the inspiration of the scene, it's glitter. And actually, when I was developing this, I was thinking about like my time in like high school or early college, where me and my friends would like get in a car and drive to San Diego, which is a beach city in California. And then we would go to the beach and then like get totally baked in the car, run to the beach and throw ourselves underwater. And I just remember the beach is so beautiful and the water is so clear that when you submerge yourself underwater, open your eyes, you can literally see what felt like miles away. And while you're in the water, there's a lot of shit going on. There's like these little gold dusts or reflective metals or reflective rocks or whatever. And they'll be spitting and stuff in the water. And every so often, it'll be at a perfect angle where like the sun would reflect off the surface and cast a little quick beam of light into your eye, just for a fraction of a second. But you have that times like 100 millions of particles that are just floating around you at any given point. And it felt like a light show. It's like you're like in space among the stars, but we're stoned, so. And for the rotation, we use this thing called quaternions, and it's basically a 3D complex number. It's used quite heavily in game development for character animations or vertex scanning or anything that has to do with rotations. Basically, it's quite common because it has low memory footprint. It has 4 floats, or you can use half floats, which is fine too. It has 3 degrees of freedom as opposed to Euler angles, which actually have 2 degrees of freedom, which means that if you start to approach, say, the y-axis, you start to get this thing called gimbal lock, which is a mathematical artifact of using Euler angles. So quaternions are basically, ubiquitous in game development. And for the lighting of these particles, I initially tried to simulate a physically correct BDRF. BDRF stands for bidirectional reflections term. And BDRF is essentially a 4D lighting function which takes in like the angle from the position of light or angle to the eye. But then it came out to be too complicated, and I actually just hacked it in with this texture. I used the incidence angle, which is the angle between the surface and the position of light, and I interpreted it as texture coordinates, and I sampled it to this texture right here. And it kind of gave me a iridescent feeling to, when you look at glitter, that sort of nice iridescent feeling. So that's scene 2. The final scene, scene 3, is a little more abstract. It starts off with this wavy mesh thing, and then it converges onto this alien insignia, crop circles type of look, and it starts to absorb galactic energy and explodes into 2 million particles of light. And then, so doing 2 million particles in real time in 60 frames a second was kind of a challenge for me when I was developing this. But then I was reading some papers online from SIGGRAPH, and this guy published something called curl noise recently. And curl noise is it's quite nice because it's super fast. It allowed me to actually hit 60 frames a second with 2 million particles, so I was pretty happy. And basically what curl noise does is it tries to simulate fluid dynamics, and for fluid dynamics, one of the most important properties of fluid dynamics is incompressibility. Incompressibility is basically non-compressible. If you have bottle of water or something like that, you can't really squish the bottle of water, or you can't really sit on it, and as long as you don't affect like, temperature or pressure, I think it's pretty much constant volume, which is the basis for like hydraulics and mechanical engineering, stuff like that. And then for cold noise, you start with 3D Perlin vector field. And since 3D Perlin vector field is mathematically continuous, if you take the curl of it, which is this mathematical operator, it actually gives you a number that's non-divergent. And non-divergent means non-compressible, which means that it is a good estimate of fluid dynamics vector field. So basically, I calculated this, saved it to a 3D texture, and for each of these particles, I just sample into a 3D texture, and then smooth it. So the shader was actually about 5 lines of code just to do this entire fluid dynamic system. So it's pretty nice and pretty fast. And so those are the 3 scenes, and talk kind of briefly about the post-processing. So post-processing is sort of the touch-up to the final scene. So you render the scene into a buffer, and then you do some color corrections or add HDR or bloom or whatever, and it becomes the final scene that you submit to the screen. You can think of it as like icing on the cake or makeup on girlfriend or boyfriend in any case. Yeah, so in my application there's two post-processing effects that I coded. So the first one is HDR. HDR stands for high dynamic range, as opposed to low dynamic range. And if you think of like your screen has is consisted of pixels. And for those of you who've done like CSS or any color stuff, each pixel has 3 channels, RGB, red, green, blue. And if you have RGB values of 0, 0, 0, that gives you all black. And if you have them all 1, 1, 1, it gives you white. And the problem with using LDR is, like say for example, like you're in a game and you see like a light or something, a white light bulb that's emitting white light. In the screen, since it's white, they only can represent it by 1, 1, 1. But say like you're in the game and there's a window open and there's also the sun also shining white, which is also 1, 1, 1. The thing is being represented by the same number, yet the luminosity, intensity of the sun is 100 million magnitude greater than the light bulb. So what you do is you would render the scene into a high dynamic range. You apply a mathematical operator called tone mapping, brings it back to low dynamic range, so you can submit it to the screen buffer, or to the screen, since the screen is low dynamic range. So it gives the feeling of like brightness and luminosity. This is a scene from Far Cry 3, I think. And oftentimes HDR, like in games, HDR also goes with bloom. So yeah, so it's basically you take the threshold your high dynamic range. The pixels that are above the high dynamic range, you extract it, you apply a bloom filter, and then you just add it onto the final scene. It gives you just bloom look. Finally, I applied this thing called film grain, and film grain is used quite heavily in like, film noir and a lot of kind of gritty sci-fi games. This is a screenshot from Left 4 Dead 2. Left 4 Dead 1 has film grain as well. So the left one is film grain off, and the right one is film grain on. And film grain actually adds, I feel like it adds a lot of character, a lot of interest in the scene. And also, if you have like these gradients, like these really like lo-fi gradients, sometimes you see this banding artifact. If you add just a little film grain, actually makes it seem like actually a smooth grain. So, so this is what that glitter scene looks like without any post-processing. And this is what it looks like with post-processing. So you see like HDR, really bright particles, and this film grain that has a lot of detail, rich detail to the final render. Yep. And just really quickly, for the editor, And basically, I have everything in the scene, everything in the entire demo editable through this these GUI windows, and this basically allows me to just quickly iterate and quickly converge onto the mental model that I have or that I want to create. And I think without it, like if you're just say your engine is just in C++, every time you gotta do a tweak, you gotta do the tweak, you gotta build, you gotta link or compile, link, and then boot up the system again. It just really slow. So if you could make everything really, really instantly visible and highly iterable, I think you could have an advantage of against other demo sceners by just having a better final polished product. And then in any demo, or any good demo, there's always a nice camera system. So I implemented a camera system that you could like fly around the scene, drop a camera point, fly around another scene, drop another camera point, and then you can set like the times that you want to linear interpolate to. Yep. So that's all, and I'm just gonna try to get it running. Hopefully, it doesn't crash on me. Just give me 1 second. It's real time, moving around the scene. This is my final scene, but I'm going to hop on to scene 3 and start it up.
How do you work with the musician on this? Does he see the final demo first and then he makes the music, or do you work together at the same time?
Basically, I just sort of sketch out the general scene, and then he comes in, sketches out the music, but then aligns everything to the top of the beat of the phrase. And I just go in, take his music, and then just nudge it a little so that it matches well with the music, and it just kind of iterates from that.
Sorry. Why did you choose OpenCL over other options like directly using the
CUDA?
Yeah. Why do you use OpenCL?
Besides CUDA?
Yes.
Well, because I'm using OpenGL, and CUDA only works on Microsoft-based platforms,
All right.
and then OpenGL works with OpenCL because they're both under the Cronus group, which oversees the standard specifications. So they both can work together. Like OpenGL, you can actually pass like a vertex buffer into OpenCL and then actually manipulate the vertices and then pass it back to OpenGL, back and forth.
Yeah, CUDA works on Mac and Linux also.
Really? Yeah. Actually, it works on NVIDIA, right?
Yeah, I mean, well,
Only on
yeah. So
You're
you're
not
hardware locked instead of OS locked.
Yeah, you're right. You're right.
Do you have a size limit of the binary for the demo? Is it like a rule or something?
Yeah, so in like demo scenes, usually there's several categories. There's the main competition, then there's the 8K, which is 8 kilobytes executable, and the 64 kilobytes executable. For me, like I'm going for the main competition, the big kahuna. And for me personally, I don't really, limiting file size and doing all the hacks just to get executable size to be 8 kilobytes and stuff, it's not really, like it's really impressive that they're able to do it, but it just personally doesn't appeal to me, because I want to just try as different things as possible and just have like a nice quality music and then have nice visuals and a lot of shaders and stuff. So definitely I would not able to hit even 64K or even 10 megabyte limit. Yeah.
You said you did this in like less than a month?
Yes,
So
well, on the
is that
weekends
like
and stuff.
creating the content or actually building the whole framework and then the GUI for manipulating it and stuff like that as well?
Well, I have the basic engine, which includes the editors and all the other stuff, and the GUIs and everything. And I had just a lot of framework from my previous projects using the same engine. So I was just able to build on top of it.
What kind of hardware are you using right now?
Hardware?
Yeah.
This is a kind of an old laptop. I think it's about 4 years old. It's an Alienware. I forgot the specs. I think it's a ATI 580 or something. Mobile 580 or something. I don't remember.
So most of it is GPU work, or processor is also important?
So like fluid dynamics, just doing everything on the GPU is just pretty important because GPU is just super fast. And if you can just offload it to the GPU, it basically saves so much time.
Is the only texture that round texture that you showed? Is that the only texture?
There's zero textures.
That,
Oh, sorry.
the lighting texture?
That one texture which I used to sample for the
Yeah.
for the glitter scene, yeah, that's the only one texture I use. And also the
So if you didn't have that, you have no texture?
that and also the intro artifacts text.
Oh, right.
That's the only two textures I use.
You said you generate a texture with a code, so 3D texture. I'm just curious how much memory that takes and what resolution it is.
The resolution, what did I use? I use half floats, 64 by 64 by 64 volumetric textures. It's I think it's CL memory of that size, and didn't take that much memory.
Is that your first demo?
That's my first demo.
What motivated you to start making demos?
I always like demos. I always watch them on my free time during lunch and stuff. So I'm pretty into the whole demo scene, and I don't know. I just thought it would be interesting to make one, because especially since Tokyo is kind of close. And
Have you been to demo parties in Europe before?
no,
No.
I've never been to any demo anything. So this is my first one. What's up?
The last part reminds me of something called fractal slaves. Have you heard about that?
No, I
You should really have a look at it. It's a way to process 3D fractals that really looks like the last
Interesting.
one. Yeah.
Yeah,
And they have really great ideas in order to put some color animations and color depth into those spiraling 3 blobs.
it's raycast based or vertex based, you know?
I don't know. Flames.
Practice flames of
Flames.
Oh, flames.
Oh, do you open source that code?
Sure. Yeah, it's kind of hacked together, so maybe it's.
So you mentioned the cross-platform. Does it mean you're trying to run it on Android or iOS device?
Well, the fill rate on like Android and iPhones, like the PowerVR GPUs, feels like they're very fill rate bound. Like you can't do a lot of cool pixel shader stuff, so probably not. And also I'm using the OpenGL, not the OpenGL ES subset, so just take a little time for it.
Could you do with this with ES?
I'm sorry?
Could you do this with ES?
Yeah, I think so. The only stuff I'm doing is just a few like media mode renders because I just couldn't be bothered handcrafting each vertex buffer. I think.